Section 6.3, the Law of Cosines. Starting in the previous section, when we talked about the law of sines, we started talking about solving oblique triangles. And we talked about all of the different possibilities of information we can start off with. Every possible combination of the sides and the angles we could be given from the very beginning. And what we found was that the law of sines was applicable as long as we did not have one of these two cases: a side angle side triangle or a side 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 triangle. So if we have all three sides, we're going to use the law of cosines. And if we have two sides and the angle between them, we will use the law of cosines. Now, the law of cosines we have three different versions of, but they're really all the same, okay? So we are going to start off with a triangle ABC, and the sides and the angles are going to be labeled in the standard manner, so that side A is directly opposite angle A, and so on, okay? Now, when we go to solve these, we are either going to be solving for a side or an unknown angle. So there will be a pair of things where we're missing one part of it for sure. So if we're looking for side A, we'll use this formula. If we're looking for angle A, we'll use this formula. Side B, angle B, so on and so forth, okay? Now what you may notice is that if you cover up this part, we have something that looks very similar to the Pythagorean theorem. Now, we don't necessarily have a right angle, although it could happen. So we don't know that our C is the hypotenuse. So that's what makes it a little bit different. But it does look very familiar, okay? And in fact, the law of cosines is an extension, a generalization of the Pythagorean theorem, okay? So what we're starting off with right here is a side squared equal to the sum of the other two side squareds, okay? So if I have B here, I have A and C here, okay? Now the rest of this is minus all the way across, 2 all the way across, and then B times C, which are these two right here. A times C, which are these two here. AB, AB. And then the angle and the side are the pair. So A and A, B, B, C, C, okay? So essentially they're the same, it's just a matter of what information you're going to be looking for. So let's look at an example problem. We are given side A, side B, and angle C, and we're asked to find side C to the nearest tenth. Since we're looking for side C, I'm going to use this formula. C squared is equal to A squared. A is 3. So 3 squared plus B squared, 4 squared, minus 2 times A times B times cosine of angle C, which is 60 degrees. So do your arithmetic here and you get C squared is equal to 25 minus 24. 2 times 3 times 4 is 24, and cosine of 60 degrees is 1/2. So I have C squared equal to 25 minus 12, which is 13. Now we have C squared equal to 13, so technically you're taking the square root of both sides, and when you take the square root of both sides, technically you'll get plus and minus 13, but since C is a side, which means it's a distance, we are only interested in the positive answer. This is your exact solution, but we are asked to round it to the nearest tenth. So use your calculators to get an approximation to the nearest tenth, and the square root of 13 is approximately equal to 3.6. Now we're not given a unit for the sides, so my answer is just 3.6. If I'd been told that this was 3 centimeters and 4 centimeters, then I would put centimeters here. It is definitely not 3.6 degrees because it's not the angle we're looking for. So let's go to where we're solving full triangles, and that means we're going to find all of the sides and all of the angles. So we're asked to solve each of the following triangles. We're supposed to round our answers to the nearest tenth, but we're not going to use rounded numbers in our calculations. So this is where we need to be pretty careful, and knowing how to use the memory on your calculators will really help you out. Now, the computer questions are better about this, but I know several of you use the textbook and the questions at the end of every section and the answers in the back of the textbook to get more practice. And on those problems, if you are using your rounded answer, your answers will never match that in the back of the book, and you will think you don't understand anything at all. So what I'm going to do, if we're going to solve every triangle and we're given side A, side C, and angle B. Well, I'm going to set up my chart here for all of the things I do know and I do not know. So I don't know angle A, I do know angle B. Angle C I do not know. Side A is 6.8. Side B I do not know. And then side C is 2.4. Okay? Now I'm going to look at my formulas and see what I have. If I want to find angle A, I need to be using this formula. But to use this formula, I need to know side B, which I don't. If I want to find angle C, I need to find side B, which I don't have yet. So my first step has to be to find side B. So I'm going to use this formula. I have my side A, I have side C, and I have angle B. So that's enough. I have B squared is equal to 6.8 squared plus 2.4 squared minus 2 times 6.8 times 2.4 times cosine of 10.5 degrees. Now you want to go to your calculator, make sure that you are in degrees before you start typing everything in. 6.8 squared plus 2.4 squared minus 2 times 6.8 times 2.4 times cosine of 10.5 degrees. And I get that B squared is approximately equal to 19.90, so forth. Okay. I'm just writing this down so you can refer to it later to make sure that you know how to enter everything in your calculator correctly. Okay. Now we weren't asked to find B squared, we're asked to find B. So take the square root of both sides. So I'm taking the square root of the previous answer, and I get this value. So 4.461676794. Okay. Now I'm going to put this value into my memory on the calculator. So on this calculator, I hit store, and just because it's the first variable that comes up, it's X, but that's going to be my B value. If I really wanted to, I could push this multiple times and actually assign it to B, but that's going to get annoying. Okay, so now anytime I just push X, that same value is going to come up. So this memory is storing the exact answer for B. We are asked to actually round our answers to the nearest tenth. So when I go to enter my answer, I'm going to say that B is approximately 4.5. But for the rest of my calculations, I'm going to use this full value. Okay, so I found B. Now I need to find angle A and angle C. So I look for where I have angle A, which is right here, and now I have every piece I need except for that A. So I'm going to plug in side A squared equals side B squared. And I'm not going to write this in because this will help me remember that I need to use the calculator button, where I have it in memory, plus C squared. Okay. Minus 2 times A, no, not A, times B times C times cosine of A. Let's make sure I've got that correctly. A squared is equal to B squared, which I'm going to use from memory, plus C squared minus 2 times B, again using memory, times C is equal to cosine of A. So, first thing I'm going to do, just because it's going to be easier, is, and I'm not going to write down this whole value right now, I'm going to do 6.8 squared minus B squared minus 2.4 squared is equal to negative 2B times 2.4 cosine of A. Okay? So if I do that, and then, well, again, I'm not going to work on this whole calculation yet until I have to. Then I would divide everything by negative 2b times 2.4 to get just cosine A by itself. Okay, and then, so all of this cancels out and I'll have simply cosine A. So what do I have? Cosine of angle A is equal to, now I'm going to plug this into my calculator. So I have a fraction, 6.8 squared minus B squared, which I have B plugged into my variable X, minus 2.4 squared. And this is over negative 2 times X times 2.4. And I have approximately negative 0.960, so on. Okay, now to find a value for A, it may not be the one we're looking for, it may not be the only one, but we'll find our angle A could be inverse cosine of that. So I'm going to figure inverse cosine of that answer. And I get my angle A is approximately 163.9 degrees. Okay. Now remember, with cosine, our other possible solution would be, when we were solving them before in the last chapter, we did 2 pi minus, but since we're in degrees, I'm going to do 360 degrees minus this. And I get 196, which is too big to have in a triangle because we certainly can't have one angle at more than 180 when they're all supposed to add to 180. So that's not a possibility. And our A value is 163.9 degrees. Okay, now what I'm going to do is I'm going to take this exact value from above. I'm going to add 10.5 to that. And then to find angle C, I'm going to do 180 minus that solution. And I get approximately, we went around to the nearest tenth, 5.6 degrees. And that's our solution. That is our whole triangle solved.